thanks Rob and to the McEwen group for putting this session on. It's great to be able to be here. I spent my last 30 years at PwC and was their global mining leader. Had another of other leadership positions there throughout the years. And once I decided on what I was going to do for my next career, I started talking with Artisan, which is looking at technology for mining. And I know the mining industry needs technology first to help address the cost side, but also to address a lot of the corporate social responsibility issues, the greenhouse gas issues, the health and safety issues. And what this, what battery-powered electric technology does is it helps address all of those. And I want to talk a little bit today about, I can talk about the health and safety a little bit, the greenhouse gas, but everybody knows that and that everybody feels that. I think what's really important is the cost side, so I'll focus on that a little bit. The markets, the mining industry has certainly been a challenging one over the last few years. I still have, I remember Rob McEwen giving this speech once and handing out, I forget the dimensions, but I still have it at home, but he handed out a Zimbabwe currency note, and I think it was $100 billion or something like that, to really drive home the point of how debasing impacts gold prices and in an inverse relationship. We've seen the U.S. do a lot of debasing, and now I think the world is not believing anymore that interest rates are going to go up and that debasing is going to stop. And I think that we're seeing some favorable impacts on gold that I think will drive people, the mining companies, to get into this technology and to make the investments in what they need to do and get the right long-term benefits in this. So I've just been with the company for since January, so a very interesting 6 months. I've said throughout my career I was a mining industry expert, and I've now the last 6 months I realized that was a lie. I really didn't know much about the operating side and how the engineering side of mines work, and I've been learning a lot about it, and it's been quite interesting and eye-opening to see what's out there. I'm going to go through first. Let's make sure I can keep on time here. So that's our advertising, which I'll get back to later. Electric's been around for a while in the mining industry, and I know Dave and with the Valley team up in Sudbury has been certainly been using that for a long time. A lot of deep mines there that need this technology for ventilation issues. But the way they've been done has not typically been with battery. There's been some battery applications, but for the big pieces of equipment, such as the haul trucks and the loaders or the scoops, those have been done by either using trailing cables or, in the case of scoops, or overhead catenary lines in the case of the haul trucks. And there's been some challenges with that. The cables tend to be, they'll run well for a while, but occasionally you'll run into an issue where they're too short on one end, we might say, right? They just run out of room and you can't go where you really want to. So that tends to be the issue with the trailing cables. If they can have some very expensive maintenance, the equipment can go out of production when you need to replace them. They're very expensive to replace. So there were some challenges that have brought out that, yeah, they're still in use, but they haven't been as popular as they could be. The overhead catenary lines, again, work great. But they're expensive to put that infrastructure in place in order to run those. So that's been some of the challenges with the electric technology that's made this happen. The benefits that people are after when they go towards electricity is, one, they're on the cost side, they're looking to reduce their ventilation costs. So ventilation is very expensive. The airways that need to be built when building a mine are expensive to build. The fans are very expensive. The cooling plants, if needed, are very expensive. I know we're looking at one deal where the mining company had to have 15 megawatt cooling plant, and that was a very challenging and very expensive proposition. And I understand South Deep in South Africa that mine had 125 megawatt cooling plant. And these are, if people were, cringing over 15, imagine 125 and what that does for you. So that whole CapEx part is a very important one in the mining industry that can be addressed with electric. On the operating side, it's also important because they can the power cost to drive that ventilation down is quite significant. And the savings that can come out when we can reduce the power requirements and the airflow requirement, reducing any reduction provides a higher cost savings than you would think. So if you can reduce 40% of your CFM requirement, you're going to save more than 40% on your power. And the reason is how this is explained to me. And my analogy that I like to give, I'm a canoe trip guy, so I buy bags and all compact stuff that I can fit in my bag and make it as small as possible. So when I get my sleeping bag, I'm stuffing it into the bag. And first few times I stuff it in, it's pretty easy. It flows down pretty easily. The last one, I'm kind of like really pushing to get it down. And that's the same thing with the airflows. You try to get that last sort of 20% of your airflow down. It's a lot more power required to push it down the mine than the first 20% is. So it's an interesting way to look at the savings you can get from going with electric. The labor efficiency is another very important part of this. I was talking with one mining company, and they were operating in a hot jurisdiction in the U.S., and they had this wonderful way of framing how labor costs are when they're operating in hot places and how it's more expensive in the U.S. And the way that they said it was there's some there's some aspects to the spatial dynamics of the U.S. workforce that make them need more frequent breaks when it's a hot temperature. And I kind of like that because basically what the person just said is they're carrying a few extra poundage in the U.S., so that kind of makes them not be able to work as hard. But that is some of the issues that when you are underground, it's going to take a little bit more. It's going to suck a bit more of your energy out if the temperature is really hot. And if you can go to an electric solution that has a cooler working place, that's great for labor efficiency. The heat generation by equipment starts out being roughly a third if it's electric equipment versus diesel equipment, and that's because of the efficiency of the equipment. So when diesel equipment does work, of the power that goes into the diesel equipment, 30% of it actually does the work, and whereas with an electric equipment, 90% of the power that goes in does work. All the power ends up being heat, but that means you can do it with a third of the power. You can get the work done with electric. So a lot less heat is being generated. There's some other aspects that also result in less heat, and that's the braking. When braking on a diesel equipment, the braking generates heat. When you brake with electric equipment, the way we design our equipment is that the braking function regenerates the battery. So it does not give up heat, it actually regenerates, which actually saves on the amount of power that has to go into the battery to charge it. Health and safety standpoint, and I should have led with this. Every mining meeting I go to, we always want to talk about health and safety and the impact. And the diesel fumes are cancer causing. The World Health Organization's labeled them a carcinogen. There was a case in Quebec, lower level case, but the mining company was found liable. The worker who had worked there for 25 years had cancer and ended up taking an action against the company and was successful. And from some mining companies I talk to, it's just Quebec. It's just a lower court. We're not worried about it that much. But the reasoning behind it is this can happen. It's not outside the realm of possibility that this can be expanded. I get that mining companies can't go out spending crazy amounts of money in order to make things 100% safe. You can't make things 100% safe in a mine. I get that point. But as the technology gets better, I think this is going to be something that needs to be looked at hard from a risk management perspective, from the mining company's perspective. And greenhouse gas is certainly very popular now. It's coming down, so there will be some extra savings that come in from the greenhouse gas credits that come up in cap and trade. I want to go through quickly about what's happened and why the technology is where it is and why we're excited that battery technology is here and it can make things happen. We've had our systems in place at Kirkland Lake Gold for almost 5 years now. Since the first LHD went up, we've worked with a couple of different OEMs up there, and they now have, I think, 27 pieces of battery-powered equipment. So this isn't it isn't a new technology, but it uses the lithium-based battery chemistries that have allowed the additional power to be generated that can power the haul trucks and can power the scoops that are going through their mucking cycles. That was a challenge to do with some of the other chemistries that have been used for years doing locomotives and things like that underground. What's happened is around 10 years ago that the lithium-based chemistries came into vogue. Tesla started using them in their Roadster in 2008, and in 2010, we were asked by Kirkland Lake Gold to start considering solutions using these battery chemistries that can help power the underground at their Macassa mine. Lithium cobalt has been the chemistry that's been used by Tesla. It's a fabulous chemistry in one sense, in that it has a very high energy density. One of the issues that we've seen with batteries is that they don't last the full shift. We need these things to last a full shift for miners to be really comfortable with using them, and we've seen that they don't last, and that's because of this concept of energy density. So you need to have enough energy in the battery cells that you can create the power you need for as long as possible, and lithium cobalt has a really good energy density, so in one sense it would be great for mining, but we won't touch them with a 10-foot pole, and the reason is that there's a fire hazard with them. The stories of the Dreamliners going down because of battery malfunctions, that's been lithium cobalt batteries, and I get Tesla using them in cars above ground, but if a fire is going to start in your car, hopefully you'll have enough warning. You can pull over on the road. You can watch your lovely car burn, but it's not like everybody's going to die. An underground fire is very different. You can't have a fire underground, and we're not willing to take that risk with lithium cobalt. So we need to give up on that wonderful energy density benefits that lithium cobalt has and look at some others. It's my dramatic picture of the fire risk. So the chemistry that we've gone with is lithium iron phosphate, and that's the one that's in all of our vehicles that are in use in Kirkland Lake. We're not saying, oh, we're just going to use this and not others. We're following all the other chemistries, and we will use them at certain times. If lithium cobalt becomes 100% safe, we'll use it in a heartbeat. Right now, it's not there. Lithium iron phosphate does not have the energy density that the lithium cobalt batteries have. So if we have haul trucks that are going up steep grades, fully loaded, they're going to need to swap their batteries. We're not going to be able to last full shift on it. A lot of the scoops on the mucking cycles can get through the shifts without a swap. That's great. There's a lot of time between shifts to charge, so they can do that. But we're not willing, we're not able at this stage to be able to get there with the big trucks hauling up ramp fully loaded. So that requires that.
Excuse me.
Yeah.
Is that an 8-hour shift or a 12-hour shift?
We've been looking at 12-hour shifts, but we kind of get that into the seat time, and that's how we calculate it based on seat time. So you can have the longer. So it could come out a little less than 8 when you look at the seat time. So there's the time to go up, time to come down, the health meetings, clearing blast fumes, and getting to the equipment. And by the time that happens, it's down to probably less than 8 hours.
Tesla claims they can change their batteries in 90 seconds.
Yep.
Robotic battery change. How quickly do you change yours?
Ours is the fastest they ever did it was, I think they did one in 8 minutes. They're quite proud of that and advertise that to everybody, but we tell people 15 minutes, 10 to 15 minutes. And what needs to happen is going into the, we will strategically place the charge stations, and the trucks will pull into the charge station. We need a 5-ton crane to take the battery off the truck and put it on the charger, take the fully charged one, put it on the truck. That's a 10 to 15 minute process. We'll say 15 minutes we model it at 15 minutes when we do our simulations to make sure the trucks can hoist, can haul the number of tons that they need to haul. Okay. On the fire side, if a lithium iron phosphate cell fails, there's no fire risk. With the lithium cobalt, that's the fire risk, is if the cell fails. If the cell fails in a lithium iron phosphate, and we've had that happen once in 5 years, it lets off a mist that isn't toxic. It's the type of thing that you might have to rub your eyes if you get it right in your eyes, but it's not toxic. It's not going to cause any harm. There's no risk of igniting. It will burn if a fire is caused, but for some other reason, this battery cell will burn, much like a piece of wood would burn. It can be put out with regular fire extinguishing equipment that you would have underground. If there was such a big fire underground that your battery cells would catch on fire, you'd probably be a little more worried about the tires on the equipment catching on fire than you would about the battery cell. So we view this as being no significant fire risk, but it certainly is something that needs to be discussed because there's this negative reaction to fire and batteries now. Lithium titanate's another interesting one that we're following, in that the lithium iron phosphate batteries take around 2.5 hours to charge. The lithium titanate can fast charge, so you can charge them in 15 minutes. That's the one very interesting benefit of that chemistry, and it's one that we're following quite a bit. There are some issues with it. The benefit of having such a fast charge is you don't have to swap, so you can just leave it on the equipment, swap in between shifts, swap at lunch hour, or sorry, not swap, charge it at lunch hour. But to do that, you need to get, if you have a 165 kilowatt battery pack, and you need to get all that power going into the battery in 15 minutes, you need to have a lot of electricity being pushed down. There's no way to get around that. And if you're going to be doing your whole fleet at lunch hour, there are some electricity dynamics that need to be addressed in order to make that work. Nonetheless, it's a really interesting technology, and one that I think will have its place. It's currently quite expensive, say 3 times the cost of the lithium iron phosphate, so it is expensive too. But again, it's one that we do like that technology, and I think it will have its place in the future. Kirkland Lake Gold's story was one that they needed to get to. They were working along the east-west fault. They found some mineralization on the south side of their property. Very high grades. They wanted to get to it. They could tunnel over, mine the product, tunnel back to their existing hoist infrastructure. That was no problem with the economics, but when they looked at the ventilation, they would have to sink a ventilation shaft, and that would have had a drastic impact on the economics, given how deep their mine was. So instead of building the ventilation shaft, they came and found Artisan, and started talking with us and a small OEM about building electric-powered equipment. We've done that. They use electric-powered equipment over in that part of the mine, and that's been a big part of the success of the South Mine Complex at Kirkland Lake Gold, was the ability to be able to do this. The second last CEO at Kirkland Lake Gold was a big Copco fan, and wanted to work with Copco and with us to start putting our systems in Copco equipment. our relationship with Atlas Copco started then. Atlas Copco's now did their global release of their ST7, which is their 7-ton scoop at CIM in Vancouver in May. So that's been officially launched. It's coming right off the production line with the electric motors and with our systems. So that now is coming right off the line. They've also done some 20-ton trucks up at Kirkland Lake Gold. I think there's 3 of them now. And Kirkland Lake Gold has 6 20-ton trucks altogether, Copco and other OEMs. There's a number of different pieces of equipment that are available, and I'm going to talk a little bit at the end about some of the smaller equipment, the 1.5 yard, and we're looking. There's not solutions that are available with our existing companies, OEMs that we're working with, and we're looking at doing that. We're looking at building one of those ourselves, and we're starting to do that. So I want to talk about that a little bit later. Those are the different sizes of motors that we have. So one of the benefits is we can do the full fleet. That's it's kind of interesting to have the same equipment that's available, so the same parts. The traction motors are these ones, and they're the same across all the equipment sizes. This is the auxiliary motor, and this is the main motor. In the smallest one, we just have the one motor, but that one motor is the same as the auxiliary motor in the 2 bigger size structures. So we do have a motor that does the equipment, and then a separate one that does the hydraulics, so that there's no competition for the power coming out of the battery.
Is there a limitation in how big you can't drive a 40-ton truck with these power systems?
That one we can do the 42-ton with this one. With this one. Yep. Yep. Yep.
Is that the limitation? Is it sort of
We can build the engine to do any size of truck. Where the issue comes, and right now it's at anything above 50 ton, it gets to be a challenge. But what the challenge is where we're going to put the battery packs. In a truck, we have to put the battery packs where the diesel engine would otherwise be. And as trucks get bigger, the engine size, the diesel engine size, does not scale at the same rate the payload does. So the amount of room we have for battery cells is not as much. So we can't get enough battery cells in the trucks that are going to be carrying 70 or 80 if we get up to those 80 tons. So we need higher energy density. We need to get those lithium cobalt batteries underground.
Making hand grenades.
Yes, we need to. We need to start a bonfire underground, and we can haul as much as we want. But no, the technology will catch up, and it will get there.
Well, the batteries can be distributed all over the truck. I would have thought.
Yeah, and we've looked at having 2, but they're big. They're big. So the motor itself, we can kind of slide anywhere. So the motor itself is quite small, but the battery pack is quite big. Like this, the battery pack that would do. Let me go to the next slide here. Yeah, that battery pack is like 3 tons, I think. Like they're huge.
Can they be distributed over
Sure,
a large truck?
Yeah, you can, but you need to find the room.
Yeah.
You need to find the room, and you can't. There's only so much additional fabrication you can do to put in more batteries. But yes, you can have them around the truck for sure. But it still gives us a challenge when we get above 50 ton, in my view, right now with the current technology.
Yeah.
John, could
Yes.
you have some sort of fire suppressant on a lithium cobalt battery to get around that issue you have?
It's a really dangerous fire. It doesn't need oxygen to burn, and it can't be put out with fire extinguishers. So you could bury it, I guess, to put the fire out, but it's really challenging fire to put out. That's the issue with lithium cobalt. It's a scary, scary fire. You let it burn. So if your Tesla catches on fire, you let it burn.
Need for fire both in the battery, and that's the problem.
Sorry?
The 2 components that you need are both in the battery. It's like having the oxygen in the gasoline tank.
Yeah. Yeah.
Squeeze it
Yeah.
out.
Yeah. Yeah. So you can cut the oxygen off. That doesn't stop it.
It's the problem you're going to bump up, because as soon as you have a safe battery, the engineers are going to increase the density in power.
Right. So it's challenging to put out that fire is a very challenging fire to put out, which is why we're staying away from it.
And how do they put it out now?
Let it
Just
burn. Let it burn. Yeah. Yeah.
Okay.
Which is above ground on the side of the highway is fine. Let it burn. But underground, it's not fine. Right.
And how much smaller would it be than, say, in your largest size?
A lot. I don't know how. I don't know exactly how much because we're not doing them. So I don't. But it would be. It's a lot better energy density. And I think the way to look at it is you'd be able to. Let's say with your hauling. Let's say with the duty cycle for your haul trucks, you have to swap twice during the shift. You probably wouldn't have to if you could do cobalt. So it really is a great solution. Except for the fire. Except for the downside.
Aside from underground, do you do them on pits too or no?
The main.
For the pit, you can let it burn.
In the pits it can be done. The main, from an economic standpoint, the main benefit that you're getting from going with the battery solution is you save ventilation costs. You don't have to do the airways, you don't have to do as big of fans, cooling plant. With an open pit, ventilation's free, so you don't get that savings. If you want to go for it for the greenhouse gas and for the the other benefits that it brings, you could. And some companies are looking at doing that, and you could look at those chemistries for that. Yeah. And of course, there's the chargers that we have. The master charger, which is this bad boy. When the battery connects to that, it sends reports to our office. So we get reports on how the batteries are functioning. We can then have live communications with the maintenance group to discuss maintenance protocols and what needs to be done. So we then get detailed information on duty cycles that we can use to plan out what the equipment can do. So we're pretty confident with our ability. We have over 100,000 hours of hours underground. We're pretty confident that we can map out with a very high degree of accuracy how long we can go on a certain ramp, on a certain grade, how far we can go between swaps. So we get a lot of useful information from this, and that's available to the mining companies to the extent they want to get data in order to help run their business and manage the mine. A lot of data comes out of the scoops and the haul trucks through that comes in every time they go to charge. The next 4 years, some of the things we see. So we've looked at mines haven't been designed for downhill carries. Typically, they haven't been good ideas. You just your driver has both feet on the brakes as hard as humanly possible. You're creating a lot of heat. You're wearing down your equipment. With battery, that changes dramatically. You can have, this is one area where you can have the bigger haul trucks, because if you can plan your mine so that your hoisting is at the bottom of the ore body, you can then haul downhill fully loaded and come up empty. And you will never have to recharge your battery using power in that case, because the braking goes directly into regenerating the battery. So gravity pays for your fuel bill. It's even better than solar, isn't it? Gravity is a nice source of alternative. How's that for a source of alternative energy? Gravity. So that's an interesting part of how you can build a mine to take advantage of some of the things that battery-powered electric can bring to the table. And then I think we'll see that happen more often as more mines come online, taking this into account. Ore passes, some people like them and some people don't. One job we worked at, they've had a lot of challenges with ore passes and poor ground conditions, getting clogged up, halting production while they have to fix it. And they just decided, hey, let's just get rid of all these ore passes and we'll just haul downhill. It's free to haul downhill. Yes, we need a bigger fleet to do it. We have to worry about congestion, but on balance, it at least gives you this option you can consider. If you still want to go with the ore passes, you can still go with them, but this does give another option that allows you to think about how you may want to do things. In the pre-production phase, driving ramps. So if you've financed your mine, you're going ahead, you're building it, it's your sole project. Markets foaming at the mouth waiting for this thing to come in production. If you can go to the market and say, hey, we can bring this thing into production 3 months earlier than we said before, that's going to get a very positive reaction on your valuations. And how battery can do that is you can have some pretty significant limits on how much horsepower you can throw at driving a ramp until you can get a good ventilation source. You're driving your ramp, when you get down to a certain stage, until you can hook up with a ventilation shaft, it's really tricky to get to be working with diesel going down into that ramp, and you may have limits on how much equipment you can throw at it. If you go with battery, you may have some options to have more horsepower be dedicated towards that process of driving the ramp. Same thing would happen with doing bulk samples, where you have to drive down to the ore body. Same would happen if you're doing an exploration at it. There's a lot of you can reduce the timeline by throwing more horsepower at those functions. How much time do I have? 5 10? 5 10? Okay. Thanks. The CapEx, we've done some detailed stuff. Well, we haven't. The smart people in the world who know mining engineering have done some detailed studies. We've looked at a mine that had done its feasibility study based on diesel, and it then redid it based on batteries. So this gives us a really interesting comparison of the different costs. Kirkland Lake didn't do that. They knew what the CapEx number was going to be if they went with diesel to do the ventilation shaft, and they just wanted another solution, and they found one. And they didn't really do this kind of A versus B trade-off study. But this other one was a very interesting scenario. So they were looking at doing it's a base metals mine. It was deep. It was hot. They had the diesel plan, and it was going to be expensive to ventilate. So they went through and looked at it from an electric equipment, battery-powered electric standpoint, and looking at full fleet. And what they found was the airflow requirement went down by 40%. The number of the number of airways went from 4 to 3. And they really thought on that on an optimization study they might be able to get that down to 2. That was a significant CapEx reduction. They were able to reduce the size of their cooling plant quite substantially by 25%. The number and size of their fans was reduced. All in, this generated CapEx savings of $50 million, and there would also be annual savings from reduced power costs down the road. So this is a very, very powerful full option for them, and really is going to change really is going to pay for the equipment by having that CapEx savings. Now the issue is, if it were only a gold mine, it would probably be going ahead, but it's not, unfortunately.
What was the original CapEx on the diesel?
It was around 200 million, I believe. 200 million.
So you cut a quarter off.
One thing about gold prices coming up and the market coming back is I think that's going to lead to some pressure to go towards zero emissions. One, I think a lot of mining companies are going to really want to go towards that if they can make the cost side of it work and do it profitably. But I also think there's going to be some pressure coming from governments, and governments have been holding back. They know that they know that the diesel particulate matters are dangerous, but they also don't want to put the mining industry out of business, and that's good. That's good. I don't think they should be putting in regulation that puts puts half the mines out of business. But with the gold prices going up, there may be some more pressure to go towards these types of solutions, just from a health and safety standpoint. And I think now that we have this, now that we can get the cost side working, that's a wonderful opportunity to move on these alternatives. I think it's going to be led by big miners, so that'll be led by Glencore's, Vale, Goldcorp, Those are Barrick. Those are the ones that I think will be leading it, and others will come up. I think the Kirkland Lake being the first one to really go out and try this was really fact specific, and due to their management team at the time saying, let's just figure it out and do it, and really being open-minded and looking for alternatives as opposed to just discarding the South Mine Complex. But now I think this is going to be something that's going to be there's going to be big companies that are going to be driving this. They're going to come out with building mines with zero emissions, and that will lead others to follow. We're building a scoop now that's in the 1.5 yard size. And it's because of a demand, and we've been working with Copco. They don't have that product so we can't get a battery version of it. And we're going to do our own, because that equipment is needed, particularly in the narrow vein mines. And when we do it, we're a Californian-based company. We think technology. That's the way we think, and there's going to be. Technology is going to be brought to the scoop in everywhere, shape, or form that the mining industry can use. We've been one example of this, and I'm just going to give a simple example. There's going to be others that we're going to that will be included. We're going to be unveiling this at Mine Expo in Las Vegas in when is that? September, I think, or October. So one of the things is, when there's a problem with the scoop, it's going to be highlighted. The operator will be able to have live discussions with the technician. The technician can take control of the scoop and be able to operate it much the same way as your IT department does when if you're bumbling like I am on the computer and can't figure it out. You talk to some guy who just takes control and clicks on all the right things and fixes it. So that will be done. It'll be totally integrated with the parts. So that if parts needed, it gets ordered, it goes to the purchasing group. So that function will all be automated within this scoop. The other thing that we're going to do is there's a lot of technology now that's coming, and we want to be able to build our equipment so that it can accept the technology when it comes. Part of our company in California, we've hired some of our engineers from the aerospace industry, and the thinking that comes along with that is, much the same as you would think of in the aerospace industry. So our theory on this is build hardware that's a lot more than you need, because there's going to be solutions that are going to come up in the aerospace instance. It's up when you're up in Jupiter, you're going to have some new software that you can push down. You want to make sure the hardware is going to be able to handle it, and that's what we're doing with our equipment. We're going to have the hardware capabilities when it comes time to when new software is available to handle different technology functions that the mining industry needs. There's going to be the capabilities, so you don't have to go out and buy a new scoop. It's going to be ready, and you're going to be able to push it down, and we're going to help make that happen. So a lot of the things that everyone's talking about, remote mining, autonomous mining, people are getting new efficiencies from battery technology that are coming. People are looking at reporting, getting access to data, getting these reports from the scoops. What do we do with it? People come up with new ideas. It's going to be a push of software into the equipment so that we can get this coming up. And again, the key thing is the longer battery life and the performance. We've done our new battery size now, our new battery cell that's going to be available for the 40 ton plus equipment. That's going to be available with better performance, and that's going to get better every year. And we're going to be able to push that into the new equipment as and when it's available. The 1.5 yard scoops that we have are going to have 3 times the power that the diesel variety would. Main reason is they can do the diesels that strong, but the emissions rules won't let them. We don't have those rules to worry about, so the performance-wise, those scoops are going to be much better. Okay.
Is the biggest challenge going to be along battery life and performance over the next 4 years?
That's going to be that's the biggest opportunity, because it is going to get better. It's going to get better. They will perform better. They will perform longer. We'll get more power into a smaller area. We'll be able to go with the bigger equipment. The energy density is going to get better on batteries, and that's the issue. If I have to say where the issue is now, it's not with scoops. The issue is with haul trucks, because going uphill fully loaded, you just can't go the shift. You can't even go anywhere close. You need to do a couple of swaps during the shift, and people look at that and they go, oh man, we have to swap. That means 15 minutes we're going to be down. How about if something goes wrong? There's a lot of hesitation on that, and I think the solution to that is mapping out what the impact is going to be on tons that you're hoisting. We need to look at this from a tons perspective, and a lot of times where mines have had a goal based on tons, we're able to get there, but we're going to be able to get there in even more situations as the technology gets better.
Very cool.
Okay. Okay.